So I'm Rodrigo. I'm part of the core SRE team, cloud management platform SRE at Pinterest. We deal with deployment tooling and service framework for most of Pinterest.
And I'm Ruth. I'm on the core site reliability engineering team at Pinterest, which means we're responsible for overall uptime. And part of that, of course, is reactive, but hopefully at least 70% of that is proactive, and we're building the systems to be more reliable. So a few numbers about Pinterest and the scale that we're dealing with here. We've got 200 million plus monthly active users, 150 terabytes of data processed daily, hundreds of services, and what's the last one over there? And tens of thousands of machines. So just to give you an idea. And for those of you that don't know, Pinterest is to help people discover and do what they love. So Rodrigo is actually really into leatherworking. If you are interested in that too, you should ask to see his wallet after the talk. And I like to do a lot of baking. This is a try on Pinterest. And I also like to do a lot of DIY. So this is something I found on Pinterest that I laser cut for my friend's shaving set. So this is the way that we're going to structure our talk. We're going to have an intro, which is a backstory about why we decided to migrate to containers, a bit about our architecture around containers, and then finally the war stories. So to start off, why containers? And so when we first did the rehearsal for this talk, we were like, wow, it's actually really boring unless everything is war stories. So everything will be in the context of war stories for this talk. And so the first reason that we decided to go to containers is that configuration management is really hard. And the way that we had it set up, we were just really bad at it. So we use Puppet for our configuration management, and you can imagine our Puppet repo is a mess of copy-paste. There's unknown code. This has led to incidents where like something was notified to restart when you changed it. And so it restarted across the fleet, and we didn't realize that that would happen. A recent incident that this happened to us was for service discovery caching. So we have that running on every single host. And of course, if that is restarting across your fleet, that's bad news. Another example is having stuff pinned to lattice. And so we have a security service that's on all of our hosts that does things like reporting what containers are running on the host. And we had a new code feature caused its backlog to overflow, and then the default behavior for when that happens is that the logs go to the kernel log, and there were so many logs that the kernel log wasn't able to catch up, and so the machines would freeze and not be able to do anything until these logs were caught up. But you can't blame the developers about knowing about like obscure Puppet things like lattice and like notify. They shouldn't have to learn these things to be able to deploy their service. So just a bit about masterful versus masterless Puppet, as we call it at Pinterest, or using Puppet masters versus using distributed Puppet. We started off using masterful Puppet, which is when your hosts pull the configuration down from the Puppet masters, and then we've since switched to using a distributed Puppet, which is when the config is in S3, and then they're pulled from there. And so these are some reasons that we switched from masterful Puppet to masterless Puppet. So we found this to be really confusing for developers. There's multiple ways to do things. There's the Puppet dashboard, and there's also the version-controlled repo. And so it's hard to know what actually is the configuration right now because it's in different places, and it's hard to know where to change the configuration. So it's just like really confusing. We also didn't have any staging for configuration releases set up. So if you deployed something, it was deployed on all of your infrastructure right away. And so one example of this being kind of a weapon of mass destruction was we uploaded a bad NSCD configuration once. And so as this was rolled out across the fleet, our latency went higher and higher and higher. And from all of our debugging tools, it looked very much like a network issue. And so this took us hours and hours of Pinterest being down to figure out what was going on, when in fact it was actually the DNS caching that had a bad configuration. Another issue that we've had with Puppet Master is that it's kind of a bottleneck for scaling. Often our Puppet Master certs will expire, and then new hosts that spin up won't be able to do the handshake. And then our most epic failure that we've ever had with Puppet is that, I don't know if it was cosmic radiation or what, but on the configuration it said file, F-I-L-E, But then as the configuration was pulled down from the master on the host, it would get changed to FILD or FILF. And so the file was changed into a symlink. And this was a problem because the file in question was actually the PEM file. So a significant proportion of our machines could not be logged into, and we had to figure out how to get back into our infrastructure. From anyone in the audience, what was the longest migration you've ever had to do? How many years? Can I get a hand? Somebody shout out a number. Worst migration ever. 5 years. 5 years. So I guess we're not so bad. It's been 3.5 years and still counting, so 1.5 more years before we're at 5 years. But the masterful to masterless Puppet migration has just been really hard for us. As SREs, this is a lot of toil work. So we've had people who decided that this was not the job for them and left, or and so when we first started this migration, we were at about 10,000 machines, and that was when we started feeling like the master full Puppet solution was not the right scale for us. And so it's been hundreds of services, 2.5 years, and still ongoing. And so something that's been helping us with this is just migrating, instead of from master full Puppet to masterless Puppet, to just migrating straight to Docker, and then having all the machines run on the same underlying infrastructure. So some more notes about how we were using configuration management in the wrong way. So Puppet actually configures SSH for us. So if you've messed up your Puppet configuration, you can't log into the machines, which means you can't see what the error is. And so we've written a whole separate service just to fix this issue that's baked in the machines and will let you tail the logs, let you see the logs, even if Puppet is not working. And then also updating shared modules, especially when you have developers doing it who aren't necessarily familiar with Puppet, can cause many things to break, and it's difficult to track. For example, we have a common.yaml where a lot of the machines use this configuration, and if you update something and you introduce a package dependency conflict, like for example updating Bodo, which we did recently, this causes new machines to not be able to deploy, and because our service is auto-scaled, this is a huge problem when we get more traffic during the day. We also don't have a very good release system. I mentioned for the master full Puppet, we had no release system. For the masterless Puppet, which is the new system now, we have a canary, which is 10% of the hosts. So when you make a change, it goes out to 10% of prod, and then you can promote it to 100% of prod, and that's it. That's all the rollout process that we have, which also makes it hard to catch things that are going to be catastrophic failures. And then finally, it takes 30 minutes for Puppet to run the first time. So if you're auto-scaling, this is a very long time for your machine to come up. Another thing that we're kind of using Docker for is that we're using Docker as a glorified package manager. So imagine it's 3 a.m., you just been paged something, and you go and you're like, okay, restart my service name, I'll try turning it off and on, and it doesn't work, service not found. So you're like, okay, initctl list, and it's not there. So, all right, we'll try something else. That doesn't work, we'll try something else. Monet is not even a process manager, but some people use it that way at Pinterest. And then there's some other options as well. We've got Ubuntu 16 process manager. And this is really hard to remediate incidents when a lot of your different services are started in a non-standard way. And so with Docker, it's just Docker restart my service, and you know that it's the same everywhere. And then lastly, the container runs the same way on dev as in prod. For example, if you have a different version on your dev machine versus prod, that can cause a failure that you wouldn't realize until you put it into prod. And one example of this is often Ubuntu library packages will get updated, and if it's a security update, sometimes they'll take the old version out of the Ubuntu upstream. And so we've had that cause auto-scaling failures where you can't actually download the package that you've pinned it to in Puppet, but it works fine on your development machine because you already have something installed. It just doesn't work when a new machine is spinning up. And then also, this kind of migration is a forcing function for standardization of the way that we have our services set up. So a little bit about the architecture that we have at Pinterest. So in the old model, each service had its own profile with configuration, and this meant that for me, many of the requests that we're getting from developers are like, hey, Puppet is broken, can you help me fix this error? which sucks. And you can understand why it's confusing. There's lots of different ways you can configure something. So say you want to, you need a new version of Boto 3 because you want to include the newer AWS regions. You can change this on the base AMI. You can change this in Puppet configuration management. You can change this in your deploy config, or you can change it in your process manager like virtual environment. And so that's really confusing for developers. Whereas in the new model, all the developers have to worry about is their Docker file, which is their container configuration. So Puppet is still running. You still have the base AMI, but this stuff is now standardized to be the same across all machines and all services. And also, this means that Puppet failures do not cause a deployment failure, because now they're separated. So this is a bit about what the workflow looks like for you if you're a developer at Pinterest. So you have your Docker file, which is the container config from the previous slide. This gets built into the Docker image, which gets uploaded to our container repository. And then we have our deploy tool, which deploys the container onto the host. And also, if you have like service discovery configurations, or if you have managed data configurations, that's pulled in by the deploy tool. So something special that we do at Pinterest with containers is sidecars. So sidecar is a helper service that runs alongside your main service. For example, configuration caching, log aggregation, metrics, routing proxy for memcache, which is called mcrouter. And so if you have these sidecar services, you can configure it so that you can have multiple different services running on the machine that all need log aggregation, and then you only need one instance of the log aggregation container running to service everything else. And this is a good point for why containers are not VMs. You wouldn't be able to do this in a VM because it would be isolated. You wouldn't be able to share like that. So here's an example of a container configuration. This is a little bit like Docker Compose that we have at Pinterest. So you have the configuration for your service. You say what image you need it to pull from, what user it's going to run as. You can set some environment variables. So if you have a different database, for example, for dev versus prod, then you can set that here. And then this is what the sidecar configuration looks like. So you can say, this is my logging configuration, and you can pass in the configuration for your service into the logging sidecar. And then finally, of course, we're all aspiring towards container orchestration. So at Pinterest, that hasn't happened right now. So right now, we just have one service per host, which is a little bit silly. But what we're doing is that while we're doing this container migration, we're also setting up a Kubernetes platform. And so when we're done both those things at the same time, we can bring them together and have container orchestration. And the war story behind this is that if you're choosing between Mesos or Kubernetes, don't do both. So a year and a half ago, when I started at Pinterest, we were looking at Mesos. We felt like it was more validated at the scale we were at. So we started using Mesos, and we're still trying to maintain that infrastructure. But now we've decided that Kubernetes, especially with our sidecar system, they have daemon sets in Kubernetes, which are like basically sidecar. We're building our Kubernetes platform, but we still have to maintain both, and that's a lot of work. All right, war stories.
All right, so why containers? For various reasons that Ruth mentioned, and for my worst nightmare of a war story is every time I get called at 2 a.m., I have to figure out what's broken. Is it a dependency that's changed? Did somebody make a Puppet configuration change yesterday that worked perfectly in the existing hosts? However, for our auto-scaling, it just doesn't work. It's broken, so I get called. So Puppet has helped us solve containers have helped us solve quite a bit of this. Most of our failures now happen at the build time versus at the deploy time or scaling time. So what if I told you I had a system that would solve a bunch of your problems? Great, right? However, what if I told you this solution would also add 20% latency, network latency, to your service? You tell me I'm crazy, right? No way you're going to use it. So that's actually what we found when we first started migrating to Docker. We're using the Docker overlay network. I believe that's Docker Bridge Network, sorry. So after much testing, we actually decided not to use it. We started using the host network on all of our Docker machines. So our containers are actually started with host networking, which gets rid of this performance issue. So When we first started migrating to Docker, we started testing out various applications on it. One of the ones we tested out actually was Zookeeper. So what if your application's running fine for 2 months, no issues whatsoever, and all of a sudden it just stops responding? What do you look at then? No errors, there's nothing, no issues. So you go, restart the service, it's working fine again. A couple hours later, it stopped responding. What do you do? So after much digging, we actually discovered that by default, the JSON log driver in Docker is blocking. So as soon as its log buffer got full, the application would just stop responding. So this is actually, so as soon as we migrated away from logging to standard out inside Docker, the problem went away completely. Docker has actually added a new logging mode that you can choose. I believe it's in 1.14. However, it uses a ring buffer. And you have to be careful with this. We care very much about our logs. However, if this ring buffer becomes full, it will just start deleting old messages. And if you care about your logs, this can be an issue. So OverlayFS and Cron. So we say Docker helps you solve the issue of testing in dev and in production, and it should all work the same, right? And most of the time it does, except for this one instance. This actually took me quite a few days to figure out what was going on. So Cron has a little bit of a security feature that doesn't allow it to run any files that have more than one hard link to it. So that's great. However, when you go to OverlayFS, OverlayFS actually uses hard link as a way to save space and share files between its layers. Well, test and dev works, goes to a prod box, it doesn't. And this is because on your Mac versus prod, you're using different file systems. So a quick and easy way to fix this is to just touch your files before you actually start using them inside a container. This will make a copy of them and get rid of those same hard links for you. So auto recovery. So you migrate to Docker, you get rid of your init systems, great. However, your application crashes, doesn't come back up. Well, that's a bit of an issue, right? So you set your applications to always restart unless you specifically tell it to stop. Okay, well, your applications are restarting. Awesome. However, those applications sometimes crash. And if they fork, they can leave behind zombies. Those zombies sometimes have file handles on the resources you need. Well, if those files handles are taken and the resources are taken, your application can't restart. So unfortunately, a lot of the applications start inside Dockers, those zombies will never get cleaned up. So to do this, we actually set a init system inside a container so that whenever your application dies, it actually ensures that any zombies will get cleaned up. So we do this by actually setting --init on the Docker daemon itself so that our developers don't have to worry about any of these issues. One other one is when you're upgrading Docker. So if I set Puppet to upgrade Docker across my infrastructure, I don't want things to die. And it has happened before, especially when we first started testing this out. So you actually set your Docker daemon with a --live restore so that even if Docker dies, your application is still running. Great. So Docker's your init system now, and then killer comes around and actually kills your Docker daemon. Your containers are running, which is great. However, a month later, you have to deploy your application again. Well, Docker isn't responding. What do? So to solve this, we actually set a score on our Docker daemon, so it's one of the last things to die. So whenever we actually need it, and especially since we're using it as an init system, it actually works. So often Docker issues really aren't Docker issues. We get contacted by people quite a few times on a daily basis for this. One of the most interesting ones is a Java application that we had that was being migrated to Docker. Right after they migrated, they just started seeing crazy memory leaks. What do you do then? It's a Docker issue, right? Well, this actually made me lose quite a bit of sleep. So I stayed up pretty much the whole night trying to figure out what the hell was going on. And after a few hours, I actually discovered that they hadn't just migrated their application to Docker. They actually had upgraded the OS version as well as the JVM. Unfortunately, glibc and the version of JVM that they're using had a bug in it that it would allocate memory and would never deallocate it. Very unfortunate. So if you're ever migrating, try not to migrate too many things at once. It will make debugging a whole lot easier. All right, so migrating from Puppet to containers. So the second application I migrated to containers, I had to go and figure out exactly what the requirements for it were. This took me 3 days, and that's because I look at Puppet quite a bit. Unfortunately, if you're a developer, you most likely never look at Puppet. So, and it's just unthinkable for anybody to go and spend 3 days finding out all your dependencies, right? So we've actually tried to automate all of our dependency discovery. So we've automated logging discovery, configuration discovery, and dependency discovery and configuration discovery for other developers. For Java, we actually even went further. So we have a standardized build pipeline that will convert your application to Docker for you. Unfortunately, this isn't true for all the languages of support of Pinterest, but we keep building tooling to make developers' life easier. So what has containers got us? So provision time for a new host went down from about 30 minutes to 5 minutes in some cases. We've migrated over 1/4 of our infrastructure to Docker in a year. New services are still being onboarded on a weekly basis. So just to capitalize here, immutable deployments. Catch issues at build time, not at 3 a.m. Ensure your applications can auto-recover under most circumstances. Migrate one thing at a time. Make debugging easier for yourself. And automate migrations. This helps developers actually take the effort and do it themselves. So containers are easy. Migrations are very hard. We're hiring. Come talk to us.
We're taking questions now. If anyone has any questions, there's a mic here. There's a mic over there.
Talk into the microphone.
Is it on?
It is not on. That would indeed solve your problem. Let me point that at your face, too.
Thank you.
You're welcome.
So during your migration of 1/4 of your infrastructure into containers, have you come across any particular applications that you found were just completely not well suited for containerization, and why?
So one of the things we've stayed away from currently is stateful applications. And the reason for that is just we haven't built the tooling to manage those applications. It's not that they're not suited for it. We just haven't gone and built the tooling for it yet. One of the other things we found is sometimes applications have decayed over time and have supporting scripts that need to run at certain times, and so those can be challenging to migrate as well. It's not that they're not suited for Docker, it's just that they need to be fixed before they're actually migrated.
Did you guys come up with a set of sort of blessed base images, or decide on Alpine or Debian, or do devs just have, like, run whatever image they want?
So that's a great one. That's actually caused issues for us a few times. So we have a number of blessed images and a number of blessed images with languages we support at Pinterest, and we have a list of them, and we recommend people use them. We don't enforce that, unfortunately, and so sometimes if things happen upstream, we got blocked by Ubuntu a couple times, and they're not using our own images, which point to our own mirrors of the Debian repo, that's actually caused issues for a few times. So we do have those images. We don't enforce that.
When you moved to this system, how was it working with the devs? Were they okay with moving to Docker? Like, do they use Docker Compose locally in their workstations? Like, how'd you fix that problem?
So we actually fixed that problem by migrating our largest cluster first. So our main API fleet is probably our largest cluster. So to encourage other people to migrate to Docker and to remove a lot of those doubts, that's actually the first application we moved. That's also helped us create a lot of the tooling we needed for other people to migrate their applications as well. So if your largest cluster is running on Docker fine, there's no reason any of your other applications shouldn't run on Docker as well, right?
Did it, on their workstations, what do they run on their workstations? Were they like okay with using Docker Compose, something like that?
Yeah, so we've actually been using Docker for development way before we actually started migrating to Docker. Yeah. So we have a set of tools that will just let you spin up a mini Pinterest on your development boxes, and that's been around for, I believe, 2 to 3 years now. Yeah.
Are you guys using the multi-stage build files, and if you are you running into any issues with the OverlayFS with that?
So we are running multi-stage builds for some things. I believe I'm actually the only one that's using that right now. I created there's an application in Elixir that we support that I migrated to it. We haven't run into any issues with OverlayFS at all. No. Yeah. Any other questions?
I'm surprised there's no questions about Kubernetes.
All right. Thank you very much.